The lesson outcome for this video is I can solve word problems with linear inequalities. We're going to look at a couple of examples of real-world situations where we can use inequalities to help us solve or make a decision on something. So the first example is Kiera is selling cups of lemonade. She has enough supplies to make a maximum of 120 ounces of lemonade. A regular cup holds 10 ounces of lemonade, and a small cup holds 4 ounces of lemonade. Write an inequality to represent how many of each cup she can make. All right, now the first thing I want you to think about is that we want to define our variables. Defining our variables means telling what x and y will mean as we write our inequality. The best place to look for that is right here. It says how many of each cup can she make. If that's what we're trying to solve to find the answer to it, then that is obviously going to be the answer for x and y, our variables, when we solve. So how many of each cup can she make? So x will be the number, because it says how many, so the number of regular cups of lemonade she can make, and y will be the number of small cups of lemonade that she can make. Okay, because that'll help us solve then how many of each cup. So how many regular and how many small. All right, so now to write this inequality, what we're going to do is we are going to think that there's going to be some number of cups, of ounces, I should say, some number of ounces written right here, and we're going to talk about that in a second, that can be a maximum of 120 ounces. Now, sometimes when we see the word maximum of 120 ounces, we might think greater than. But actually, if you think about the word maximum, that means at the most, which means that it has to be less than or equal to that amount. So I'm going to use less than or equal to 120 right here. So a maximum of 120 ounces means that whatever we find to put in this line here has to be less than or equal to 120. So what goes on this line right here? Well, what goes there is the addition of the number of ounces that she sells that are in regular cups, plus the number of ounces that she sells that are in small cups, like the total number. Now again, we know that a regular cup holds 10 ounces, and we know that a small cup holds 4 ounces. And then we know that this is regular right here, regular cups, and x is the number of regular cups. So we don't know how many regular cups she sold, but we know that each of those cups, however many there are, has 10 ounces. So we're going to write 10 ounces times the number of regular cups she sells. So that's 10x. Plus, we also know that small cups right here are our y value. So we know the small cups hold 4 ounces right here, but we don't know how many we sold, but we know that's y. So we need right here plus 4 ounces times the number of small cups that she sells. So again, reading this through, 10 ounces times the number of regular cups plus 4 ounces times the number of small cups. Added up together, these ounces needs to be less than or equal to 120 because there's a maximum of 120 ounces. So now we're going to use that inequality we wrote and we're going to graph our solution. So this is in standard form, and when it's in standard form, we are going to graph our solution by using the teeny tiny table. We're going to put a 0 in for x and find y. When I put a 0 in for x right here, that should be a 0, sorry, my pen got caught. If that's a 0 right there, 10 times 0 is 0, so that kind of goes away. So we have 4y is less than or equal to 120. If I divide both sides by 4, I will get 30. Okay, and now I have to do the same thing by putting a 0 in for y. So if I put a 0 in here for y, 4 times 0 is 0, so this goes away. And again, this is not new to you guys. And now we divide both sides by 10, to solve for x. So 120 divided by 10 is 12. So there are our x and y intercepts, and we're going to go ahead and graph those. So 0, 30. So our y-axis, I'm just going to use this right here as 30, because that's the number we need to plot. So there's 30 right there on my y-axis. And now I need to plot 12 on my x-axis, so we'll go ahead and estimate this to be 12 right here. And we'll put a dot there. And then remember, this is less than or equal to, so it can equal 120 ounces. So we're going to graph this solid. And now we have to decide where we are going to shade. I'm going to use the test point 0, 0. Okay, again, that's right here, 0, 0. I'm going to test that point out. When I do that, I get 10 times 0 plus 4 times 0 is less than or equal to 120. This is 0 plus 0 is less than or equal to 120. So 0 is less than or equal to 120. Yes, this is true. 0 is less than or equal to 120. Since that's true, I'm going to put a T right here. This point was true. If that point is true, that means we're going to shade on the side of the line that includes that point. So there are all the solutions for this situation. So then the last question here, can Kiera make 8 regular cups and 10 small cups? Well, let's find out where that point is on our graph. 8 regular cups. So if we know that this is 12 right here, 8 regular cups would be right in here. And then 10 small cups would be right about here. Now, again, my graph wasn't graphed with all the nice lines on there, but I will let you know that it's right there on that line. So let's take a look at that. So if it's right here on the line, 8 comma 10, right on the line, is that true or false? Well, that works. It's on the line, and remember the line is part of our solution, so the answer is yes. Okay, let's try this second one. Kevin is selling small paintings and large paintings. Large paintings sell for $14 each, and small paintings sell for $5 each. He wants to make more than $300. Write an inequality to represent how many of each painting he can sell. All right, so again, X is going to be, in this case, how many of each painting. So number of large paintings. I won't write paintings for right now. And Y is the number of small. So what we're looking at here is $14 for each large, which is X, plus $5 for each small, which is Y, and he wants to make more than $300. So we want this to be more than $300. Right? Okay, so let's graph this solution. Again, it's in standard form, so we're going to use our teeny tiny table, put a 0 in for X and put a 0 in for Y. Why don't you go ahead, pause the video, and find those two values and then check back to see how you did. Okay, what you probably found out is that the first one is an odd value, a decimal value, 21.429. Okay, and the second value is 60. Our x-intercept is 60 when we put a 0 in for y. Okay, so we can still plot these. We just do our best with the decimal. It's almost 21.5. All right, so 21.5 on the y-axis is going to be, let's just estimate that to be, let's do 10, 20, 30, 40. So 21.5 will be right about here is our y-intercept. And 60 as our x-intercept, so 10, 20, 30, 40, 50, 60. And 60 is our x-intercept. And is our line solid or dotted? Well, it is dotted or dashed because we want greater than $300, not equal to, just greater than. He wants to make greater than $300. All right, so there's our line, dotted or dashed. And where are we going to shade? All right, again, pause the video. If I were you, I would test the point 0, 0, and decide where to shade. What you get when you put 0, 0 in is you get 0 plus 0 is greater than 300. Well, 0 plus 0 is not greater than 300. So we're going to shade away from this point. This point was false. So we want to shade the other direction. So the question down here, can he sell 15 large and 18 small paintings and still make more than $300? Well, if you remember, our tick marks there are by tens. So 15, comma 18 would probably be right around here. It's actually right on that line. So this time the answer would be no, because the dotted line is dotted because it has to be greater than 300. Let's try another one. What if I said, can he sell 10 of each and still make more than $300? That one might make more sense to you. So where is 10 large and 10 small? Well, 10 on the x-axis and 10 on the y-axis. That's this point right here. Is that good enough to make $300? Or more than $300, I should say? No, it is not. So that would be no.